Okay, so let's start recording again. Okay, so good afternoon, everyone. So welcome to the presentation video for assessment number 2 of course 2638-2766, Cloud Computing Foundations, the practical project on cloud technologies. So my name is Nhật Truan, and here's my student ID. And this is for semester 1 of 2025 at RMIT University Vietnam. So before we jump into the demonstration of the technologies, I'd like to remind our audience about a few things. First is about the agenda. Today's presentation is going to have 7 parts. First, we're going to show the creation of the VPC, and then we're going to create so the 4 ways of hosting a static website using an EC2 virtual machine, S3 budgeting, Elastic Beanstalk, Elastic Load Balancers, and auto scaling. We also are going to demonstrate a little bit about the usage of the auto-scale policy, and then some full stack web application deployment follows. And we're going to hand things up with a software architecture design. Now let's talk about the project topic a little bit. The topic for this project is to deploy a simple digital infrastructure for coffee shop business once it's online. So without further ado, let's move into the main demonstrations of today. First and foremost, we just talk about the creation of the VPC, the virtual private cloud. It's just the beginning of every project in the cloud industry. So a little bit about specifications of the VPC. So you can see it has started for this with availability zones, subnets, root tables, and the internet gateway. But showing and the result should be similar to be like this. But showing those screenshots is not enough. So let's go to the AWS Learning Lab again. So you can see this is the elements of Learning Lab 85848. You can see here from the courses. And here's the screen. Let's move it again. The process of the connection to this may be a little bit long. So we're starting up with a VPC. The VPC has 4 different subnets attached to it. Let's go to the bottom. Here, you can see this is the VPC 0FB4976 and blah blah blah. 10.0.0.16 is the CIDR. And you can see the results. It has 4 subnets, 2 public and 2 private, representing 2 availability zones, 1A and 1B. Each of them is connected to a specific root table specified here, the main one and the existing one. And an internet gateway is also a part of the VPC as well. So literally, the VPC has 7 resources along with several different materials that's attached to it so far. For the purpose of this assignment, and to make sure that the VPC is ready in the scratch way, so I just create a sample HTTP is the VPC creation. There are only 2 at 19. Remember that this VPC is only creation for the purpose of this video and will be deleted afterwards, after the video. So soon back. Those are demo VPC only for the purpose of this video, and only this VPC will be used in the next test. Talking about the next test, well, let's go on and deploy our static website in various ways. So the first and simplest way to deploy the static website is use the EC2 virtual machine. So the EC2 virtual machine, just switch to the lab later on. We also set up the instance name, the time, the image, the security group, the website software needed to run, and then unzip the website source code inside the server. So let's go to the EC2 now. EC2. Running and change the landing page, but it's not now. And running EC instances here. You can see this is the EC2 for task B. You can see it has a public IP address, which is also the elastic IP allocated to here, but just elastic IP or IP that will not change even with the, the host or refresh the page. It's connected to the VPC in the task 1, public set number 2 of it. Amazon Linux image bot key pair, and it's protected using the security root of WebSG with the ID of 0E264 blah 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 with 3 protocols 43 80 22. Now, to confirm that the website can be accessible, just click here on the address public IP. Switch this to HTTP and see the website runs perfectly. But to visualize more what's behind the website, we just connect to the instance using the bot key that I mentioned earlier today. So let's wait for this to establish. So you can see. So why for that? Now let's talk about these data websites here. So it's very simple to know. By just sudo su and then cd bar www.html. You see the source code file has been presented. So this is not a blob site. It has the source code here included. So let's turn it off and move to the next part. We're talking about the simplest way. So let's go a little bit more harder by deploying it using a stable storage service or S3. Everyone's favorite choice of website bucketing. So setting up the S3 buckets is simple. First, you state the bucket name, and then you specify the sub VPC, enable the standard website hosting function, which I will explain later. Then upload the website contents, set up the policy, and then test the result from the endpoint. So now let's move to the S3 buckets. Server storage in the cloud. So you can see the S3 bucket. Let's see the bucket. It has all the files here. You see the CSS, images, and the HTML file. Is the instance what is the bucket property. And this static website function can be changed with just one click. Here's the permissions, which include the bucket policy written in JSON, provide access to the object stored in the buckets. Access for is also attached to the VPC in task A as well. Now, when everything is ready, let's go to the property and test the endpoint from here. Perfect. So you can see 2 separate versions of the site, but one's general contents. So far, so good. We have went through the setup of hosting the website in an EC2, in S3, but now let's move to a different, but might be a little bit kind of a messy way. Elastic Beanstalk. So Elastic Beanstalk used the Tomcat platform to host the site. Tomcat sponsored by Apache, and it is the #1 choice for DevOps user. And to set up the Elastic Beanstalk in just very simple way, then just first set up the Apache Tomcat, then open the zip file, the EC2 deployment, the subnets, but you can test and run the site. Let's go into the Elastic Beanstalk. Elastic Beanstalk. In the Elastic Beanstalk, it starts with an environment. You can see there's a lot of activity is going on out there on the instance because just recently we deployed the newest version of that. Because in the Elastic Beanstalk, users or developers need to deploy the app many times in order to make sure that the Elastic Beanstalk still runs normally. Here's the help. Since launch, finish updates. The monitoring service metric is also available on here as well. By hours, utilization, 1 week, And here's the platform details, Tomcat 11, 2021. And the website is actually located here in this domain. Just let's see. So perfect running. So 3 versions of the cafe: EC2 cafe, S3 cafe, Elastic Beanstalk cafe. Now we are talking about the virtual machine. So talking about a cloud bucket. We're talking about the Beanstalk tree. But now let's talk something a little bit more high about a the equal match. Is the elastic load balancers hand with auto scaling as their friend. Now, talking about the elastic load balancer, it starts with EC2. So let's go back to the EC2 once again. The EC2 load balancers. Those load balancers are a little bit expensive, so people need to have a change of it. So to see load balancers, it stick to the target group here. The target group has some instances also running in here from the load balancing, but they are unhealthy, so people can just re-register it to make the instance, the load balancers healthy again. So let's register the target. So while we are waiting for the instances to drain themselves, just let's talk about the target group. So you can see the target group type of instance, the protocol is HTTP 80, HTTP1, into the VPC 0 FB 49, 6, P6, P3, so on. IPv4 address time, and it's donated to the balancer that I presented earlier today. So monitoring. See what's 1 week. Health checks. And intervals. Successfully registered to top. There you can see the process is now healthy again. So let's go back to the load balancers. Let's update it. You can see the elastic load balancer is active. It's the network mapping identified to the VPC task 1. The resource map with the 2 healthy instance and 2 of the broken instances destroyed. The security is still the web SG from the original instance task 1. Monitoring, duration, the attributes you can see here, and the capacity. Now, some people may not know that how can we access the the website from those balancers. Actually, you can see there's a price here from the A record, and just copy it, then paste to the here. But it may take some, if you did it correctly, you can see the result exactly the same. So now let's summarize the things. In the first 4 parts, in the next part, we have taken everyone through the journey of the VPC and the ways of hosting static website in different environments. So you can see here is the pattern again. EC2, Beanstalk, S3, and the ELB. 4 cafes, but only 1 owner. So that's how the way you host a cafe in a perfect way. Now, to assist with those 4 sides, you need 4 sides in 4 versions will be heavy. So it's auto scaling to the rescue. Auto scaling to the rescue, as you can see, is the scaling. The launch template is this one. You can see. Sorry. And the AMI detail, the instant type, the bot key, all here. Now let's do it. The serial name is 2 to 4. The security name is above. Integration with the target group number 2. There's no latest target group yet, but it will be refreshed soon. So here are the instances as the management here. You can just click here to refresh. And now let's do it back to the scaling policy. So far, we have taken everyone through a journey of one static website in 4 different ways. But for now, let's change taste a little bit with a full stack web application. So the full stack application is hosted in another separate instance, separate from the instance in the first part. So let's go back. And we'll drag it up to the bottom. Here's the dynamic website. It also has a public IPv4 address, or also allocated with the elastic IP pool, and connected to the same VPC over private subnet 1 lab row. Body is as the key pair assignment, and is the base that starts here. And in addition to the website, there's also a database system that helps the product as well. So it's from the Amazon RDS. So let's go to the RDS Aurora. You can see that we have a database instance Aurora here. The CPU is 341% class DB micro. US is 1B with exact VPC in here from the touch 1, and the web sub and the subnet format. The web SG is also here as well. It's the subnet group for the DB, and the security and the VPC is also attached with a security group that's specifically designed for the usage of this database. You can see there's quite a lot of things going on here, so it will be hard to find which is the correct one. So we can access from this ID. Is the database subnet group. MySQL Aurora has been accessible. So let's go back. So we are talking quite a lot about the technology so far. We're talking about 4 ways of hosting one website. But talking about technologies alone is very bland. So we're going to finish it up with a software diagram. So you can see the software diagram is as follows. Starting from an actor, which like a user of the source code academic website, along with the technical team. Those slides are going to be taken to the public subnet where they're being stored in the S3 bucket, and also to the private subnet containing the AWS database. There's also is going to be connected to the EC2 instances and the ELBs, which all is a part of a security group that I mentioned earlier on, WebSG. And of course, there's also the component which is the VPC. Why the VPC? Because, like mentioned earlier in part 1, the VPC is the beginning to every task in the group cloud project. So it will not be a cloud system without the presence of that VPC here on the side. And you can see all the scaling is also a part of the process as well. So in summary, you can see from 2 projects, it can be developed to an entire cloud system with the participation from bucketings, scaling stuff, the beanstalks, the databases, the virtual machines, the virtual networks, and subnets and furthermore. And this presentation of the diagram also concludes the presentation for the assignment number 2 of the cloud computing course. So thank you again for your attention, and I hope to see you on the future projects and interviews. Thank you, everyone.